In circular chemistry, feedstocks should be renewable rather than rare or finite. It means recovering molecular value from chemical products, for example plastics or metals. New chemical products make it possible to design more sustainable, healthier and energy-saving buildings, using new materials in glasses and double or triple glazed window structures. Fluorinated products permit the production of high-quality insulating foams. Biodegradable and water-based solvents are used in paints and green coatings. Fluoropolymers and engineering plastics are used to increase the fire resistance and safety of buildings. 10% of global greenhouse gas emissions are caused by clothing and footwear production. Chemistry collaborates with textile and footwear industries to increase the implementation of renewable materials by using sustainable fibers, improve recyclability performance of dismissed fashion garments, reduce water and energy use, extend the useful life of clothes. When we brush our teeth, hands or dishes, we think that more foam means more hygiene and cleanliness. The surfactants, which are responsible for the cleaning performance of detergents, are mainly obtained from petrochemical sources. More recently, thanks to chemical innovation, the sector improved its functional, environmental and energy performance, introducing sustainable raw materials from oleochemistry, improved functional bioactivity thanks to the exploitation of identified natural microorganisms, and enzyme technologies, lowering the necessary washing temperatures to remove dirt stains and allowing for significant saving of energy in the household. Every year, about 30 million tons of plastic waste is collected in Europe, 85% of which is still incinerated, exported, or landfilled. This is not only a source of CO2 emission, but it's also a waste of valuable resources. Innovative technologies can chemically break down polymers in monomers, transforming plastic waste into valuable secondary raw materials to produce new chemicals that could be utilized again for food packaging, refrigerator parts, mattresses and carpets, reducing the need to exploit fossil resources to produce virgin plastics. The choice of materials is determined by technical and quality requirements. Today, many industries use high-quality recycled materials that originate from waste production. The microfiber is made of recycled polyester and waterborne polyurethane. The recycled polyester, derived from textiles and PET bottles, is already reused as an interesting secondary raw material to produce, for example, high-quality interiors of cars. Obtaining carbon from nature. CO2 naturally exists in the atmosphere. Plants capture CO2 through photosynthesis while growing. They can build carbon in their structures using only water, carbon dioxide, and solar energy. This is also referred to as biomass production, which can be used as a feedstock in bio-based chemistry. Obtaining carbon from plastic waste. The chemical industry transforms waste into precious resources. With chemical recycling technologies, the industry has developed complementary solutions to mechanical recycling to recycle mixed or contaminated plastic waste that otherwise would be incinerated or sent to a landfill. Chemical valorization of CO2. One significant source of concentrated CO2 is represented by the emission streams pumping out of large industrial production sites. It's possible to capture the CO2 before it enters the atmosphere and recycle it into carbon. This carbon is then reused as a feedstock for existing chemicals, chemical building blocks such as methanol, for example, innovative intermediates and products, as well as renewable alternative energies such as biomethane. Since new value is given to the carbon from CO2, we often refer to this innovative trend as chemical valorization of CO2 and/or carbon capture and utilization, CCU. To conclude, the better you know your chemistry, the better you know your world. It's not just about the objects you use. Everything you do, hear, see, smell, taste, and touch involves chemistry and chemicals. With an enormous range of complex interactions between you and the environment. The chemical industry is going through a period of great challenges, with digital transformation and sustainability significantly impacting trends on a global scale. Chemistry represents the main driver for innovation in our manufacturing industries, improving the sustainability profile of our materials economy, doing more with less. Chemistry 4.0 means circular economy and digitalization, making changes to the design stages and implementing new production and material recovery paradigms to maximize the use of existing molecules, from linear production models to circular models. Chemistry will help us solve many current and future issues: sustainable energy and food production, housing and fashion, managing our environment and promoting human and environmental health. The EU action promotes a circular economy by supporting the development of clean material cycles, a reduced use of hazardous chemicals, and easier recycling methods, making sure we preserve our environment. We need your help and expect your contribution too. In small ways, each one of us can and must become an example, a direct agent for the circular economy to succeed. There's really a lot we can do. And we bet on chemistry. It's good for you and for the environment.